Okay, that's great. Let's start on with the session today. Yesterday we were discussing about, like as Vishnu said, that if there will be million of order of n, then what will happen? So Vishnu, if there will be millions of order of n, then obviously it is going to take much time. But if there are like, just a minute. Yeah, if there are like a limited number of order of n, you can say constant number, then in that case, you can say that like it will be almost order of n time complexity. Clear?
Yeah, actually, this just thought came into my mind that when we are focusing on ON square, we
Mm-hmm.
are overlooking ON, but in practical
See,
life,
why are we overlooking order of n has a reason. Just a minute. Yeah, so here, just a minute. If I'll say that this is your n square and here is your n. Okay, and I am taking n value as, let's suppose 1000. Okay, then tell me what will be the value of n square?
10 to the power 6.
10 to the power 6. And what will be the value of n? Just like n as specified, it will be 1000. Getting this?
Yeah,
So here we will find out what will be the percentage of n that is going to contribute to n square. Okay,
yeah.
percentage of n while getting added.
Yeah, that's clear. In this part, can understand that it will
Mhm.
always be lower than n square
Yeah,
because
but
it's
we'll
same
see
thing.
how much. So
Yeah,
if I'll write here n value as 1000 divided by the value of n square, that is 10 to the power 6, correct?
yeah,
Into 100. If I'll find out the value for this, I'll get 0.1%, right? That means that the part of n which is going to impact n square is just 0.1%, yes or no?
yeah,
And in the cases when the value of n is going to get increased, let's suppose it is going to be 10 to the power 4 or 10 to the power 5, then in that case, this particular value also will decrease, yes or no?
yeah.
Yeah.
Ma'am, I'm getting this part. I have a different
Mm-hmm.
question.
Yeah, yeah.
Like this question came into my mind, like when we have a for loop, when where we are having two for loops, outside and inner, then we are taking it as n square. But we are considering on a different note that there are different for loops all having different calculations, and they are all of n times.
Mm-hmm.
Mm, so there, the equation would be of on would be n square plus 1 million n.
See, now I'll tell you what you are actually thinking and what's happening. You are saying 1 million again and again, right?
Yeah.
Let's just think it in a way that you have order of n loop, which is running for like order of n. And
Mhm.
let's say it is running for n times only. Okay. If
Okay.
I am saying that n is equals to 1000. Okay. And there are n for loops which are running, So overall
Mhm.
complexity, what it will be?
1000.
No, it won't be 1000. I'm saying
Oh,
there is
okay.
one for loop which is running for order of n time,
Mhm.
and there are similar n for loops. Okay.
Okay.
Then how much will be the time complexity?
I think it will be 2n, like
No,
no,
it won't be 2n. I'm just saying
n into n.
for
N.
loop, yeah, right. N into n it will be, and it will come out to be n square. So
Yeah.
obviously, if you increase this quantity, it is going to impact your time complexity. Okay. But
Yeah.
if I'll say that, okay, you have some 10 for loops or 20 for loops or 100 for loops, it is not going to impact your time complexity that much. And that's why we consider it as an constant factor. Seeing a practical scenario, have you ever seen like a million of for loops in any kind of program which you have been through?
Um, no, just for discussion sake, this
Yeah.
came into my mind.
Yeah, but seeing the practical scenario, it generally does not happen. Clear?
Yes. Okay.
Okay. Everyone else in the class, do you understand that why we ignore this n factor? Because its contribution to the result is almost negligible. And that's why we kind of ignore it. Yes, guys, I cannot see you all responding on the chat box. Clear? Okay. What about the rest? The next very important thing is that whenever we try to find the time complexity, we see the number of iterations. Okay, we always consider the number of iterations. How many iterations are happening? Because here are several people who write their code in Python. Some write the code in Java. Some write the code in JavaScript. Okay, some write in C++, some write in C. So there are number of languages which people write the code in, and according to the languages, number of instruction varies. Yes or no? Yes. And that's why we never go into the instruction. Like I told you all that we have to count the number of instructions, but rather we prefer to count the number of iterations, because number of iterations in every language will be the same, no matter if it is Python, Java, JavaScript, C++, or C. Yes or no? Okay, so I hope you all got this part. And now coming to the number of iterations, we generally assume, like according to our programming language, that inside a for loop, maximum number of instructions that can happen, we consider the average case in this, will be 10. So overall, as I told you that in 1 second, how many instructions can be executed? In 1 second, how many instructions can be executed? 10 to the power 9. But if we talk in terms of iterations, we'd say in 1 second, total number of iterations should be 10 to the power 8. 10 less. Clear, everyone? So whenever you are calculating your time complexity, you always see that number of iterations in your program should not exceed 10 to the power 8 if your like execution time limit is 1 second. Clear to all? Now I will give you one more program. Inside this, I am assuming that some order of one statement is getting executed, and that's it. Can anyone tell me what will be the time complexity for this? I am expecting everyone to try this, and you all know that order of n and order of n by 2 is almost the same. Nothing changed. Let's see the execution of this particular program, and we will notice that what is the time complexity. Okay.
Ma'am, I have just one question.
Mm-hmm.
That if we remove the star 2, the number of execution would be n half. So
Why n half?
see, let's say n is equal to 2, then the loop would be 2, 4, 6, 8, 10, like that. And
I'm not understanding. Can you repeat?
so if I see the increment in this for loop is twice.
It's multiply, not twice.
Yeah, yeah, means yeah, 2 times I.
Yeah.
So if we remove the 2, it'll happen like I plus plus, then it'll be 10 times. And if I have it as twice, it'll be kind of half, hypothetically. I mean, just for sake of discussion. So, and comparing to I plus plus, it'll be 10 times it, and when it'll be multiplied by 2, it'll be half of n.
We can't say it precisely, right? If it would have
Approximate.
been if
Mhm.
it would have been plus 2, then you can say, okay, it is running double the original pace. So you can say it is running for half. But here it is getting multiplied. Okay. So we can't say that exactly. And we'll see in a minute how. Okay. So just see here. If first your I was equals to 1, right? First time your I will run for 1. The next time it will come, it will run for I equals to 2. The next time it will come, it will run for I equals to 4. Everyone, are you able to follow this? Next time it is gonna run 8. Next time it will run 16. Yes or no? Talking about the number of iterations, how many iterations were done when I was equals to 1? I am talking about total number of iterations. Okay, every step we will calculate. When your I was equals to 1, how many iterations has happened? 1. When your I was equals to 2, how many iterations has happened? 2. When your I was equals to 4, how many total number of iterations has happened? 3. Similarly, 4 and 5. Everyone, are you able to get this? Can you find some relation between your I value and the number of iterations? Just tell me that. I'm waiting for your answer. Okay. The question is, Aman, that the number of iterations and your I value are somewhere related. Okay. So can you tell me that? Okay, let me tell you that. In your first iteration, I value was equals to 1. In your second iteration, your I value is 2. In your third iteration, your I value is 4. Fourth iteration, I value is 8. And fifth iteration, your I value is 16. Just if you will see it in a way, it is like 2 raised to the power, whatever your iteration or I is, minus 1. So initially your I was equals to like 1. 1 minus 1 will be 0 and it will give you 1. Similar thing happen here. 2 raised to the power I minus 1. I value is now 2. 2 minus 1. It will give you 2 raised to the power 1, that is 2. Are you all getting this? So if I talk about the, like this is your first term, second term, third term, fourth term, fifth term. If I talk about the kth term, can you tell me its value? Can anyone tell me the kth term value? It will be 2 raised to the power k minus 1. Perfect. Everyone, are you able to get this? I can see 3 to 4 people responding, but the remaining class is still quiet. Guys, what happened? Okay, let me ask one by one. Abhijit, are you getting this? Aman and Ashish? Yeah, 3 of you respond fast. Abhijit, Aman and Ashish. Bhuvnesh. Okay, Bhuvnesh. must have responded. Jyotsna, Kishore, Mohan, Prashant. Okay, what is the kth term? Rohit, we are assuming that somewhere when this loop will continue, we will reach a term which we have named it as k, because we can't just continue like fifth, sixth, and seventh. So I have taken a term k, like which will come ahead, or you can say a general term. Clear, Rohit? Okay, great. Now, you know that in the maximum case, this 2k to the power minus 1 will either be less than or equals to n, yes or no? Like it is the maximum possible case in your question, right? We will be comparing our 2k power minus 1 is less than or equals to n, yes or no? Okay, one person is respond. Yeah. Now to solve this, you all should be knowing about logarithm. Okay. Now what are log? I hope you all know about logs. I'm just telling you the basic formula of it. If log A and A is here, like both the base and the number is the same, its result is 1. Okay. If your log looks something like log A to the power B, then it's like B log A. Everyone, are you clear with this? Okay. So if I give you the term as log A power B, can you tell me what will be the result for this? It will be, I'll write the entire way to write it like this. And you know that log A and A will cancel out. Ultimately, it will become B and the result will be B. Clear? So I will take log on both ends, log base 2, 2 to the power k minus 1. Here also I will take less than or equals to log base n, like log base 2 and n. Everyone, are you clear or not? Here I will take k minus 1. Abhijit, there is just these simple formulas for the log, nothing else. If you're not able to understand, I will try to share some of the documents for the log. No worries. It will look like log 2 base 2 less than or equals to log n base 2. This thing will go out as 1. So it will come out as k minus 1 is less than or equals to log n base 2. I will consider this less than gone out. I'll just consider equal to as of now. K minus 1 is equals to log n base 2. If we find out what value we need to find out, we need to find out the value for k. So here you will get your value as log n base 2 plus 1. Are you all able to get this? And this is nothing but your time complexity. We will put this particular thing in our general term, that is 2k. Just a minute. We will keep our value of k in this particular term, 2k minus 1. What will you get here? Are you able to follow this? And there is one more formula. If a log a and b is here, that is the number in the base and the log base is the same, then they just go off and you will get b as the result. This is one more formula. Are you guys getting this? So here this log will go out. You will get plus 1 minus 1 will go off, and here you will only get n. This indicates that 2 to the power k minus 1 term is almost equals to n, which we proved in our time complexity. Clear? I just showed you all the reverse mechanism of it. Are you all clear with this? Okay. Considering the time complexity, here is your time complexity, this one. We will ignore the plus 1 part because it is a constant. So you can say the time complexity for this is order of log n base 2. Everyone, are you clear now? Anyone in the class who is not clear with the time complexity thing? Okay, I can say.
Just This blue colored thing that you explained, could you just recap it?
Yeah. You have a
So
doubt in this? Yeah.
no, when you were explaining, I got it, but when I revise it, it looks too much. So I understand, yeah, from here. So
So you
there
want to,
were
yeah,
2k minus 1 instruction. Yeah, yeah, you can continue.
you want to know like what I have written here.
Yes, like you applied log on both the sides of this
Mhm.
inequality.
Yeah.
Then the power goes in the front,
Yeah.
and log 2 by 2 cancels out.
Why cancelled out? Because its value is 1, so it doesn't matter much.
Yes.
Hello,
Yeah.
ma'am. The relation between I and number of iteration is 2 to the power I minus 1. Then,
Yeah.
then if I is equal to 4, then it will be 2 to the power 4 minus 1 is equal
Uh, uh,
to 2 to the power 3.
uh, Aman, don't confuse this I with this value. This I is the value of your I in the for loop. And here I indicates, I will just change this. I will write it as J only. That will be better. This indicates the number of iterations. Okay. That is, in the first iteration, I was 1. On the second iteration, I was 2. Third iteration, I was 4. Fourth iteration, I was 8. This is how it is going on. Clear?
Yes, ma'am. To the power 3.
So in the fourth iteration, it will come as 2 to the power 4 minus 1. That will be 2 to the power 3. That is 8.
Yes, ma'am.
I hope you are clear.
But 2 to the power j minus 1 for the first iteration, 2 to the power 1 minus 1 is equal to 2 to the power 0. That is equal to the number of iteration. Okay.
Mm-mm. This is the value of I, no? Y iterations. Clear?
No, ma'am.
Okay. What are you not able to understand?
Actually, ma'am, you have written 2 to the power j minus 1, where
Mm-hmm.
j is the number of iteration.
Correct.
Yeah, in the first case, I is equal to 1 and iteration is equal to 1. In
Don't
this,
consider I as of now. Just consider J. Okay. Your J is 1 for the first iteration.
okay, so
Right. Then 1 minus 1 will be
0 is
0.
equal to
2 to
1.
the power 0 will be
1
1. And that is what you are getting.
value of I.
Yeah.
Yeah, I got it now. Yeah,
Got
thank-
it?
yeah, thank-
Yes, Vishnu. Do you have any doubts further?
Uh, I think no.
If you have any doubts, I'm going to give you a lot of practice questions in this particular time complexity thing. So just practice those. You will be good to go.
Okay.
Okay. Yeah. It is nothing, Bhuvnesh. I just showed you that what I assumed, na, that here I just showed you that 2k power minus 1 should be less than or equals to n, the general term. So I just proved here that we assumed it in a right way. It is not the time complexity. Time complexity was here. Okay, if you all clear, then I'll move on to the next question. You all understand the time complexity for I'll say the linear search, right? The worst case, best case, and the average case. Okay. So here I'm going to give. I'm going to give you two statements for the time complexity. What will be the time complexity for this? What will be the time complexity for this? Everyone, are you able to get my question?
So if I understand the question, we have to just pick the highest order.
So according to you all, the time complexity will be, here it will be order of n cube. Why order of n square as well? Like n cube is the supreme one. So we will just write order of n cube in both the senses, right? Now, if I tell you all to calculate the answers for like n equals to 5, okay, and n equals to 100, you calculate the answers for both of them in both the cases and tell me which one is getting the bigger value and which one is getting the smaller value. Bhuvnesh, I'm not sure what you're trying to say. We have to deduct.
Like we will calculate base n equal to 1, then n equal to 2, n equal to 3, then we'll see the pattern, what is the pattern is coming. Then we have to search less than equal to n, then apply the formula. Then maybe
Yeah.
we will get.
That is the next point which I'm going to discuss. Okay. For n equals to 5, for the first equation, we are getting 975. In the second equation, what you are getting? Okay. For the second one, you are getting 5025. For n equals to 100, first equation, you are getting 5100100. For the second equation, did anyone calculate it for the second equation with n equals to 100? It is some huge value as 4001400. So you all can clearly see there is a huge difference between the first equation and the second equation value. Same goes with n equals to 100 as well. So this is one of the drawback of taking big O. That is, it cannot actually differentiate between the equations having the same time complexity. Like here we can see, we said the time complexity is order of n cube, but we can see there is a large difference in the time complexities of both of them. Yes or no? So there are many exams in which they actually test your time complexity, like time complexity quality of yours. And what they do, they give the two equations in a similar manner, and they tell, like they ask you if the time complexity is equal, or one is bigger than the second, or second is bigger than the one. So in those cases, you need to be very sure, or like you need to calculate with certain values, and then you need to tell which one is bigger and which one is smaller. Clear, everyone? Until and unless it is not said that you have to calculate your time complexity according to the big O notation.
So there could be some scenarios where if I put 5, the first one will have a higher value, and if I put 10, then the second one will have higher value. In
How
that
will it
case,
happen?
mm, sometimes if you put like negative number, sometimes.
But see, even if you put the negative number, then you should get the less time complexity in 5 as well. Now, why will you get less time complexity in 10 only?
Yeah, I mean, I'm just assuming that if the
No,
uh,
it's not the case. Just
okay,
calculate it with 2 to 3 numbers and then give your observation. Okay.
okay, fine.
Okay, then. So just like the big O use that I will say is, it just puts an upper bound on the complexity. That is, whatever is the maximum factor that is running, we just say that that is going to be the complexity of the given program. Clear? Okay, then if you all understood this, I'll just quickly give you all the questions. Just a minute. I'm writing questions one by one. Try to take the screenshots and start solving until I will write the other question. I hope you all know what is a random function and what is its functionality. If no, then it generates random values. That's it. Everyone take the screenshot for this. I hope you all have understood the first question easily and you all can tell me the time complexity for that. Everyone, did you took the screenshot? Assume that your power function is going to take constant time. I'll just write here as an assume power function takes order of 1 time. Again, here I'll say some order of 1 statement is going to get executed. Then bracket close. And that's it. You all took the screenshot, right? Take it right now if you have not. Okay, let's see 3 more questions. Then I'll just
Ma'am, it's easier to answer the question than writing the question.
yeah, what?
It's much easier to answer the question than writing down the question.
I didn't understood you.
Oh, okay. The question is very lengthy.
Mm-hmm.
Finding answer is very
Yeah,
easy.
actually I know, but yeah, there are few complex one as well. That's why I'm just initially giving you all the easy ones. And yeah, try solving the 5th one if you are finding it easy. Mhm. Aman, see carefully and then tell the answers. No, Vishnu, you look little inside the question and then answer it. It's not n square. Yeah, I'll share the web link today. Try to find the complexity for this as well. And the last one. Yeah, I'm just letting you see all at once. Just give me a minute to finish this. Imagine there is some array. Okay, like take an array on your own. As of now, I am giving you an array of 5 elements. which is having like element as 1, 2, 3, 4, and 5. You can take random values as well, take it in the decreasing order, take it in some unsorted manner, and tell me the complexity for this. Okay. Basically, you need to see the worst case and tell me what will be the time complexity. Yep. You all take the screenshot for the 8th one first. Is it taken or not? Okay. See the 7th one as well. Okay. And 6th. 5th one. 4th. 3rd. 2nd and 1st must have been done. Okay. So for the first, you all told me the time complexity. What was it? It's very clear. This is going to run for order of n time. This is going to run for order of n time. Overall, it is going to be order of n. Good. Next question. This also was very simple. This is going to take order of n square. This is going to take order of n. Overall complexity will be order of n square. Everyone clear with these two questions or not? Okay. Now let's move forward and see the third one. What will be the time complexity for this? Yeah, but you should know how to solve it. So when your I will be equals to 0, your j will run from n and it will run up to like greater than I, right? So j will run for n times, that is from n to 1. Yes or no? When your I will be equals to 0, your j will run for n times. Everyone, are you getting this? When your I will be equals to 1, your j will run from n till greater than 1, that is 2. That means it will run up to n minus 1. When your I will be equals to 2, your j will run for n minus 2. So similarly, it is going to continue, yes or no? It will continue just up to somewhere around like 1 by 1 it is decreasing. Ultimately, it is going to be 1, 2, and 3. Yes or no? So if you see, it is becoming a series of addition of natural numbers. And you all know the formula for this. Its formula is n into n minus 1 divided by 2. I'm not sure if it is n minus 1 or n plus 1. Yeah, it's plus. Okay. So if you will see, it's overall going to be n square plus n divided by 2. If you see, the overall complexity is going to be order of n square. Clear? Because n square has its upper hand. Clear, everyone? So knowing that this, like there are two loops which are running, so its complexity is going to be n square. It's a very wrong way. Try to solve it and then dictate the time complexity. Clear? Okay, so I solved up to 3. 4th, 5th, 6th, 7th, and 8th is your homework. Try to do it today. If not, then we will solve it tomorrow.
Ma'am, one quick question.
Yeah, yeah.
Uh, so in the exam or interview, generally will we be asked to show the breakup, like how I'm going? Like if I would just see two for loops blindly, I'll say n square, because
Uh-huh.
even if it is n into n minus 1 or whatever way we'll get, the end result will be n square.
But there can be a point where there are 2 loops and the complexity is n. What will you do in that case?
Uh, I can't imagine such a situation.
Okay,
Means
so
the inner loop would be just working for one time, then it's obvious. But if it is also going for some variable times, then two for loops will always end up in n square times.
yeah, right. But the thing is that there are chances now that like it may run up to n time. Having 2 loops and still may run up to n times, right?
Yeah, there's a possibility if the
Yeah.
inner loop is just one time.
So you can't just blindly say that, okay, its complexity is going to be order of n square, right?
Yes, yes.
So for your own reason, you should be knowing how to calculate it. Clear?
Okay.
Because in the interview, no one is going to ask you what's the breakdown and all. But seeing these kind of complex questions and you blindly say that n square and that interview knows that it's not n square, then he or she will know that he's just like, you can say,
Copy paste. Yeah.
trying. No, you can say trying and like you're just guessing game he's playing, not actually calculating it.
Okay. Got it.
Okay? Yeah. Okay, then everyone just solve this particular questions. I'll just share the whiteboard link as well. So thank you for today's session. We will meet tomorrow. Thank you.